Here in 1.3, making a new offer, we're going to be looking at growth factors. Now there's some definitions that we have to know, so make sure we get these definitions put down in our notes. First of all, let's talk about exponential growth. Exponential growth is just a pattern or behavior which describes the change between a set of data. So exponential growth is the pattern or behavior of change. Go ahead and get that down in your notes. And then each pattern or behavior of change grows or shrinks at a specific rate. Right? In this case, we're talking about growth, and so we call that the growth factor. That's the constant at which it changes. Now, the growth factor is also in our equation that we've been using. So it would be a to the x power, or it can look like this, a times r to the x power. But either way, it's going to be that value, which is the base. So let's just keep it like this. So the growth factor is the base of an exponential function, which would be this portion right there. And then lastly, these relationships in total are called exponential functions. So this thing in total, the a to the x, that is your exponential function. The growth talks about the fact that it's a pattern or behavior. Right? It's an exponential growth. That's what it's doing. The growth factor is that constant at which it grows. And then the exponential function is everything put together. Now you also have what's called the independent and dependent variables that we have to talk about. And if we think back to the ballots question, the number of the cuts, that would be your independent variable. If you're talking about the chess question, the square that you're on when you're putting those rubles on there, rublas, that would be your independent variable. Your dependent variable would be how many pieces of paper you'll get, right? Or the rubas on the number of squares. So that's the dependent variable. Those are the things that depend on the other thing. Right, so for example, the chessboard, right? How many rubles you have rubas you have depends on which square you're on. For cutting the paper, how many pieces of paper you have depends on how many times you've cut that paper so far. So make sure you're able to determine the dependent and independent variable. So for example, here is our example for the rubas, where R represents the amount of rubas and S represents which square you're on. Those are your two variables. In this case, this is your dependent variable, and this would be your independent variable. All right, so make sure you're able to identify what both of those are. So pause the video, make sure you have all of these definitions and definitions in your notes and making sure that they make sense to you. Okay, on number 1, it says make a table showing the number of rubas the king will place on squares 1 through 10 of the chessboard. So if you wanted to go ahead, and there is a lab sheet 1.3, you can put these things on there. Number 2, graph the points, number of square on the 4 rubas 1 to 10, and then write an equation. So you can go ahead and use the lab sheet 1.3 to answer this question. Wait, sorry, I just realized this is out of order. I thought that looked familiar, but we've already done that. Let's jump down to here. This is a new plan. So we're talking about, I think, 2 or 3 new plans. So let's look at plan number 2. So the king told the queen about the reward promised the peasant. The queen said, "You promised her more money than the entire royal treasury. You must convince her to accept a different reward." So the queen is smart and realizes, hey, we're gonna go broke if we actually do this for her. And so let's come up with a new plan. So after much thought, the king came up with a new plan. Plan number 2. He would make a new board with only 16 squares. So now it's a 4x4. So that's important. So let's highlight that. It's 16 squares. Then we place 1 ruba on the first squares. So you go 1, then 3. On the second, he drew a graph. So 1, then 3, then 9, then 27, and so forth. And that would be 28. So this is at 1, what do we say, 3, 9, 27, and this would be then 81. So we're looking at that pattern. Okay, so that's plan 2. Plan 3, this is the one the queen comes up with. She's unconvinced about the king's new plan. She devised plan 3 using a board with 12 squares. So now her plan has just 12 squares. And she would place 1 ruba on the first and use this equation to fill in the rest of the squares on that 12 square table. Okay, so in this case, if you plug 1 in there, you get r to the 4 to the 1 minus 1, 4 to the 0, that's 1. Plug 2 in there, you get r is equal to, so if you have on the second square, you would have r is equal to 4 to the 2 minus 1, or r is equal to the 4, which is 4. So you would have then 4 rubas on the second square. Okay, so we have plans 2 and 3. Now this is the correct problem set here. Now looking at your lab sheet, this will make sense. Go ahead and use your lab sheet to fill out this part of the table. You can go, your lab sheet I think goes all the way to 64 or 10 if you want to go that far, but right now on this first one, let's only go to 4. Or actually this says go from squares 1 through 10. So yeah, use your lab sheet, go all the way to 10 for this one. So if we take a look at our answers here, if you haven't done this, please try this on your own. But plan 1, that's the original one. That's the original plan that the peasants said, hey, give me 1, then 2, then 4, then 8, then 16. Plan 2 is the one the king says. But remember, the plan 1 has 64 squares. Plan 2, this is the one that king said that he would do. That one only has 16 squares. And plan 3, that one only has 12 squares. So you can see plans 2 and 3 seems to grow a lot faster because at 10 on the 10th square, compare the values, right? And so that's what we're on number 1. That's what we're supposed to do. Fill that out 1 through 10, right? And then on part 2, it says what are the independent and dependent variables in each one of these? How are the patterns of change in the number of rubas under plans 2 and 3 similar to plan 1? How are they different? So go ahead and answer those parts 2 and 3 for part A if you have not already, and then come back to the video to see how you did. Okay, so for 2A, what are the independent and dependent variables, right? So the independent, let me do this here. All right, so your independent are the number of the square that you're on, okay? Because nothing else, this does not depend on anything else. So in orange or red, whatever color that is your independence, and that is the number or square that you're on. And then your dependent are all of the numbers or rubas. So what's highlighted in purple there, those are all of your dependent variables. So your dependent is all the number of rubas, all of those. Then part B says, how are the patterns of change in the number of rubas under plans 2 and 3 similar to plan 1? Well, if you look, the change is multiplicative, right? So this was times 2, times 2, times 2. And if you look at this change, it's times 3, times 3, times 3. And the plan 3, that is times 4. So these numbers here, the times 2, times 3, times 4, those are your growth factors. So these things right here, those are your growth factors. All right, so that's how they're similar. All of those are changing. The number of rubas, your dependent variables, are changing by these growth factors, and you're multiplying by those growth factors. And then 3, do the growth patterns for plans 2 and 3 represent exponential functions? So yes, they do represent growth. The growth for these are exponential. And then also they ask for the growth factors, which if you have the tables are really easy to see. And so the growth factors are here, it's 2, and this one it's 3, and in this one it is 4. So if you think about what your equations would be for all of these in the first one, so for the first one, it would be r is equal to 2 to the square minus 1. The second one would be r is equal to 3 to the s minus 1. And the last one would be r is equal to 4 to the s minus 1, because that's where your growth factor is going to be. On all of these, your growth factor is going to be that base. So now if we take a look at part B, it says write an equation for the relationship between the number of the square n. Whoops, I just did that for you, so you should be okay doing that. Make a graph of plan B. So you're going to graph that thing, and if you look on your lab sheet 1.3, there is a little grid there that you can do the graph. If you want to do that on your lab sheet, that's completely fine. And then on 3, how is the growth factor represented in the equations and graphs for plans 2 and 3? And we've already kind of talked about that. So B should be very easy for you. We've talked about many of these already. So go ahead and answer B 1, 2, and 3, and then come back to the video. Okay, on B, write an equation for the relationship between the number of the square n and the number of rubas for plan 2. So plan 2, that was the one where the king said, hey, we'll start with 1. There's going to be 16 squares. We'll start with 1, then there'll be 3, then there'll be 9. So you're multiplying by 3 every time. So our equation for that one is going to be the number of rubas, which is r. So make sure you define this. So r is the number of rubas, is equal to 3, because that describes your pattern of change. That 3 is your growth factor, to the s minus 1. And it's got to be the minus 1, because if you think about it, when you're on square 1, right, you want this to be equal to 1. So 1 minus 1 is 0. 3 to the 0 is going to give you 1. 3 to the first is 3. You don't start with 3. So that's why it has to be the s minus 1. And then s is the square number that you're on. Okay, so there's our equation for the second plan. So if you want to know how many are going to be on the 16th square, you just plug 16 in there. So it's 3 to the 15th rubas on the 16th square. Number 2, make a graph of plan 3 for n equals 1 to 10. How does your graph compare to the graphs for planes 1 and 2? So now we're making a graph for plan 3. So let's take a look at that. So here is the graph for plan 3. And you notice it does what the other graph does as well. It starts off with very little change. It almost looks flat, and then it just takes off, right? And so the change is the same as plans 1 and 2. The difference is once this thing starts to grow, it grows a lot faster than 1 and 2, but the change pattern is going to be the same. And then in part 3, it says, how is the growth factor represented in the equations and graphs for planes 2 and 3? So the growth factor is that number by which each of these y values, that multiplicative change that we looked at, we did it down here. And so these numbers right here, those are your growth factors. And so they're represented in the equation as the base right there. So the base of your exponential equation, that is your growth factor. And then on C, the king's financial advisor said either plans 2 or 3 would devastate the royal treasury. So this person proposed a 4th plan. Because even with the king's plan, if you look at the 16th square, if you look at this right here, 3 to the 15th is 14,348,907 rubles. So even the king's plan would put them under. So the financial advisor's like, hey, we can't do that. Let me come up with a plan for you. So this is the advisor's plan. The king, let's do this, would put 20 rubles on the first square, 25 on the second, 30 on the third, and so on. He would increase the number by 5 each time. He would continue this pattern until 64. So he says, let's go back to 64 squares, but let's use a different pattern of change. So compare the growth pattern of plan 4 to plans 1, 2, and 3. Is it an exponential change? Explain. And then on 2, write an equation that represents the relationship in plan 4. So go ahead and do part C, and then come back to the video to see how you did. All right. Now that you've done part C, 1 and 2, let's look at this. So comparing the growth patterns to plans 1, 2, and 3. This growth pattern, let's look at a table with all of them there so we can more easily see it. So here is our plans 1, 2, 3, and 4. And this is the one that we are looking at now. So looking at plan 4. Now, you can more easily see a pattern if you write out the table. So you notice here, this is not multiplicative change, but additive change. Like on these other ones, it was multiplicative change because this was times 2, times 2, times 2, times 3, and so forth. And this one was times 4. Right? And in the green there, that multiplicative change shows an exponential pattern. And in red here, this additive change does not show an exponential pattern. It shows what we would call linear change. Get it here? Linear. Okay, so this additive change, that's linear. So it's going to be a straight line. So in 1, compare the growth patterns. Is it exponential? So look, we're comparing it. This is a growth pattern that it's an additive change, and it is not exponential. It's actually linear. And then in number 2, write an equation that represents the relationship in plan 4. So now we need a linear change. So that's where it's going to be y is equal to mx plus b. If you remember that, where m is the slope, which literally means change, and b is your y-intercept or starting value. So in this case, we know that our change has to be 5, right? And our starting value, now this is tricky. Our starting value on this, in this case, is 20. But remember, b is where this, the independent variable, is 0. So if you think about the pattern of change, which is you're adding 5 every time, imagine if we had to go back 1, you would actually come back here, and when you're going backwards, you're subtracting 5. And so if you were to come back one at the 0 square, which doesn't exist, right? But it is the starting value, because that's where your square number is 0. Your y-intercept is 0. That is at 15. So our starting value here is actually not 20, right? Because we want to know on square 0 when your independent variable is 0. So our y-intercept is going to be 15. So you would have y is equal to 5x plus 15. Now you can test that. So test that by plugging one of these in here. So let's plug 16 in there, right? And remember 16, or no, it might be easier to plug 3 in there. Let's do this. We can do it both ways, but let's plug 3 in there. Because 3, remember, that is our independent, which is our x. So it would be y is equal to 5 times 3 plus 15. So that's 15 plus 15, that's 30. So our y value should be 30 at that point. And so you see it is 30. Right, and you can even try another one. So let's plug 40 in for your dependent. So that would be 40 is equal to 5x plus 15. And when you go and solve for x, you would subtract 15. So it'd be 35 is equal to 5x. Divide by 5. And so on that one, sorry, that would be 25. And when you go through and divide by x, you would get x is equal to 5. And so right here at 40, you are on square 5. So it works. We know that this is our equation for that fourth option from the treasurer. And then on part D, it says how many rubas for each plan are on parts or on the final square. So go ahead and try this one on your own. So the plans 1, 2, 3, and 4, you're looking how many rubas are on the final square. So looking at the first one, remember that was 64, and that's where you started with 1 and doubled on every square. That was actually an insane amount of rubas. It ended up being like, I don't even know, but 10 to the 18 means you would take this decimal, move it to the right 18 times. So it would be 922 with 16 zeros. I don't even think that I know what that's called, but it's an insane amount of rubas. Number 2, that's where the king said only 16 squares. So if you figure that out, you would have 14,348,907. We did that earlier up there as well. And then on this one, if there were 12, right, and you place 3, that's your growth factor. And there's only 12, so it'd be 12 minus 1. So if you do 3 to the 11th, that would give us 4 million. So we're still in the millions, 194,304. And then on the last one, right, on the last one, the number of rubas is equal to, plugging those into the equation, 64, that's your square number right there, right, your independent variable. That ends up being just 335 rubas. So you can see she's not going to want to choose, the peasant's not going to want to choose anything but plan 1, where she will be rich out of her mind, but plans 2 and 3 would be okay. And if we listed them from least to greatest, it would actually be backwards. So you should have plan 4, then 3, then 2, then 1, if you're listing them from least to greatest. And that is it for 1.3, making a new offer.